of sites for debates about the practice of data visualization, and he argues for lush images. He says, the best works are those where the aesthetics help people understand the data, where they're almost telling a story, unquote. Beautiful visualizations compel not only experts, but also the public, convincing them, for example, to adopt energy-efficient practices. Legibility, instrumentality, and beauty need not be discordant, I think, as this image shows. Yet currents of thought in art and design argue for the data visualization practices of both fields to be separated. Carolyn Zimkui and Robert Sara propose differentiation between what they describe as pragmatic data visualization that allows the efficient reading of data and artistic data visualizations that use data in abstract or metaphorical ways. Sara feels that creative interpretation can, quote, hurt perception, unquote, and fast analysis is needed. Yet he admits that it can also result in sublime or contemplative experiences. Mitchell Whitelaw, who has a terrific piece, as I said before in the exhibition, argues that artists should not allow their data visualizations to become designs, which he describes as an aestheticized and perhaps functionally imperative form of scientific data visualization. These positions legislate a separation between a teleological use value and an intrinsic aesthetic value. I think extracting meaning and insight from data representations requires powerful aesthetics that balance emotion, such as awe, contemplation, and deep analysis. And interestingly, recent HCI studies, such as those of Noam Trosinski, A.S. Cates, and D. Ikar, demonstrate that users pay greater attention to beautiful images and that usability and beauty are viable companions. This discussion segues into aesthetic dialogues about the sublime and the uncanny. Art and literature define the sublime, whether nature or immersive artificial systems, as a threatening unknown that cannot be fully grasped by human understanding. Sublime imagery seeks transcendence, elevating the everyday to godliness. Raw data can stand in for nature, read in tooth and claw, and nature is extended to the vast information web that constitutes the internet and digital information. Data can be perceived as primary material, not produced, concrete and objective, rather than contingent and relational. As I indicated, the last decade of data visualization saw a predominant use of natural metaphors, tree-like floral, etc., which appeared in design, art, and programmer-created works, regardless of whether the source of the data was natural or artificial. The preeminence of natural metaphors may indicate the merging of scientific and information visualization. It may represent mystification, the correlation of sublime nature and sublime data, or an ironic stance towards mystification, and it may suggest a growing sense of concern about the biological world, its extraction into data, and the need for an ethos of responsibility towards the empirical world. Issues of aesthetics and ethics are present, if not visible, in the tools we build and use. And here are a few examples of the natural in data visualization. Looks delicious, does look sort of delicious. And the Opti project, which we saw yesterday as well. And these examples, I believe Barrett Lyons is quite earnest in his use of natural metaphors. And then Julian Oliver's fantastic packet garden, which I suspect is somewhat ironic. Some artists, such as Lisa Jeff Bratt, Barrett Lyon, or Christophe Thiel, describe emergent properties and systems as an evolutionary living force. Thiel proposes, quote, metaphoresis art is investigating synthetic life by focusing on geometrical models of growth and pattern formation in silico, unquote. In the tradition of artificial life, he seeks to build models that are so lifelike that they become life. And Jeff Brett argues that genetic code melded with computer code signals a new sublime or a noble, uncanny beauty. Jeff Brett intertwines the materiality of data with programming and coding as a material and conjuring practice. And she says, to write code is to create reality. It could be likened with the production of artificial DNA, of oligonucleotides, a process where life is written. Coding does act as a means of bringing a virtual world into being through the manipulation of mathematical formula and their aesthetics as manifested through data points and computation. The study of data as a material with distinct properties, both mathematical and indexical, must not throw away the constructivist wisdom which has allowed an analysis of the intertwined relationship between knowledge and its mode of production. While human intervention is required to produce meaning from originating data, weather patterns, plant growth, mobile phone use, the transformation process should not return to romantic notions of alchemy, affected only by a cognoscenti of programmer artists, and designers. The notion of an unconscious and shared natural aesthetic is a problematic construction, as any survey of contemporary international art practice, and I think many of us were at the Istanbul Biennale, quickly suggests art is bound by differentiation. In this view, perception is relational and contextual, constructed through the complex intertwining of object, maker, and viewer. And these arguments require a located maker and viewer and militate against totalizing notions of beauty. Historical references to nature, its relationship to culture and various past expressions, their domestic chic, as in the Côte d'Ivoire story, or formalism serve as a double entendre, reminding us of the tension between the ontological and the epistemic. For some artists, an attraction to data visualization stems from the challenge of excavating hidden patterns and structures from the obliqueness of the data set, at times reconnecting these with the social or political conditions of the production. In his 2002 Data Visualization as New Abstraction and Anti-Sublime, Lev Manovich argued that visualizations of data by artists may create synthetic meaning rather than support mystification. But then Manovich indicates that there are links between early modernist abstraction and contemporary artist data visualization, kind of return of the repressed. However, the complexity and form of the structures that artists disclose have changed since the modernist era, as have the conditions of belief. Skepticism characterizes art, one would hope, not early 20th century optimism and essentialism. And the formal properties of the database are lateral and associative. It privileges the paradigm, the perception of the structure of theorization, over a narrative hierarchy. Understandings of how to treat data as material play out in the making of visualizations. Two approaches to design arise representing bottom-up and top-down process. Edward Tufte argues that data visualization requires choosing data sets that are of value to the researcher, mining the data, creating a structure for the data, analyzing that data set to find meaningful ways to represent it, analyzing patterns, translating the analysis through aesthetic representation, refining the representation to better communicate, and creating means of manipulating the data. In his view, data enunciates its own structure. There is no base case with data. It is inductive reasoning that pulls out knowledge. And through this process, they find form and sometimes also metaphor or narrative. And I love this example in terms of finding form. This may be viewed as data naturalism, structuralism, bearing a truth to materials approach, or in working with large-scale data sets representing phenomena that cannot be viewed data-driven design. Ben Fry proposes a procedure that begins with narrative or story form. He argues that the designer must start not with a data set, but with the empirical question asked by the researcher. Fry works his way back to data. Here's an example of his work. He considers the nature of the set to be obtained, finds data to fit the question, and parses these to provide a structural fit for their meaning, orders them into categories, and filters out all but the data of interest. This approach maintains the role of the scientist in producing theory. That is, theory is the base case, illustrating, testing, and deducing. It also offers an opportunity for metaphor, design variation, and the recognition of multiple interpretations of the same data set by different disciplines. Both approaches need comparative testing to see how each impacts discovery in the fields where they are applied. And in both instances, a challenge for artists and designers is to sustain a constructivist understanding of imagery while openly exploiting the indexical properties of data. So this is a fantastic sort of use of narrative and data visualization. So in developing the research methods of our visualization network, I don't expect you to read this, we've chosen to contrast these methods and to really try and approach data visualization both kind of from the bottom up and the top down and look at what are meaningful results of these. So data visualization requires both the awareness of cognitive aspects of human visual apprehension, such as color theory, and the need to make the visualization meaningful to a user's context. In a much quoted statement, Tufte describes graphical excellence as that which gives the viewer the greatest number of ideas in the shortest time, the least ink in the smallest space. and Colin Ware proposes that data visualization is the scientific study of distributed cognition between pattern mechanisms in the human brain and the algorithm that map data to the computer, connecting human cognition, computer memory, and its related algorithms, and the physical actions of the user. Indeed, successful design requires attention to the physiology of brain, hand, and eye. However, these formulae describe a mechanism at work in the perception of visualizations that are bereft of understanding the ways that human experience differs from machine, encompassing the nonlinear as well as inductive processes at work. Unfortunately, because of the focus on treating data visualizations as utilities, much cognitive science research in the field studies techniques of performance enhancement, that is, legibility and speed, rather than breakthrough, discovery, or the play of poetics or insight. Ideas about nature, reality, culture, and common sense play out in the field of cognitive science. Like scientific realism, cognitive science has gravitated towards a Kantian notion of common sense, encompassing logic, morality, and aesthetics. Immanuel Kant promotes logic, equating it with purposefulness, and demotes aesthetic judgment as mere taste. Of more value, perhaps, may be Hegel's proposal that aesthetics are a transaction between the artist, the object, and the audience, suggesting that the viewer completes the image. Certainly postmodern theory built on those notions. And there's a process, this is a process wherein an embodied subject is in constant formation, or in a state of momentariness, akin to Gilles Deleuze's notion of becoming and allowing insight and awe. So valuable lessons from cognitive science can help designers and artists, for certain, to understand differences between reading and viewing, and the ways that visuals can allow pattern recognition and text can act to lock down meaning and context in visualization. These lie in parallel to current theories about the image that reside within visual culture studies, locating aspects of cognition outside of conscious grasp. But a cautionary note is required here as well, for poetics makes use of language to create patterns, and graphic fonts such as Forte, Bauhaus 93, or Magento indicate that stylistic signifiers overcome the content that they may contain. These boundaries further dissolve in the popular field of text visualization, where semantic and social networking relationships are discovered through visual and textual patterns. Equally problematic is the tendency of much of 20th century cognitive science to universalize perception and cognition. Contrary research of cognitive science suggests that context and culture affects perception, and that viewers have different experiences in relation to what makes the same data visualization effective. Rather than a normative notion of cognition, Francisco Borello, Evan Thompson, and Eleanor Roche draw on evolutionary biology to reject notions of fitness and optimal adaptation. They use a proscriptive model in which diversity is, quote, woven into the basic constraint of maintaining a continuous lineage, unquote. And, quote, the evolutionary process shapes and is shaped by the coupling with the environment, unquote. Hence, learning and difference play key roles. Borello, Thompson, and Roche show that because understandings are culturally learned, categories such as color perception are not assumed to be objective. Hence, quote, lexical classifications of color can affect subjective judgments of similarity, unquote. This formulation links perception and aesthetic categories together. Such an approach to cognitive science requires a mix of intrinsic and extrinsic factors in understanding the mind, and allows a better understanding of cultural diversity. Sensory cognition remains of critical importance in forming judgments, and hence aligns with the need for aesthetics in the field of visualization that must take these processes into account, providing different users with varied metaphors. Even shifting color templates in the interface can allow perception and analysis of the visualization. And even when taking diversity into account, cognitive science primarily focuses on individual perception, rather than the emergence of hybrid group experience